Okay, today we're going to talk about sum or difference of cubes. So let's first start off of, well, how do I know when I have a number that is a perfect cube? I'm going to come over here and list to the side here some common perfect cubes. So the first perfect cube we know is 1. The cube root of 1 is 1. Second cube root we have is 8. Cube root of 8 is 2. Next we have cube root of 27. So 27 cube root is 3. Next we have 64. Cube root of 64 is 4. Next we have 125. Cube root of 125 is 5. Next we have cube root of 216, which is 6. And last we have cube root of 343, which is 7. So if you need an extra reminder of what some common cube roots are, there's a list for you there. So when I know that I have a perfect cube, and I actually have 2 perfect cubes either added or subtracted together, I have a basic formula I can use. So let's start with the sum. If I have 2 perfect cubes added together, a cubed plus b cubed, well, my basic formula that I can use to factor that would be a, since it's positive, plus b times a squared minus ab plus b squared. So notice the sign, if I have a sum, the first sign is positive, the second sign is negative, the third one's always positive. And if I have a difference of cubes, the only difference are the signs. If I have a difference of cubes, I'm going to be starting with a negative. My second sign is positive, and third one is always positive. So a cubed minus b cubed, I can factor as a minus b times a squared plus ab plus b squared. So let's put this into practice by looking at examples. So how do I find the cube root of 27a to the 12th? Well, if I want to find the cube root, if I write it out, I'm going to take the cube root of the coefficient. Well, how do I take the cube root of a to the 12? Well, cube root of a to the 12th is the same as writing it as a fraction. So cube root of 27 is going to be 3. And again, to take the cube root of an exponent, all you have to do is make it a fraction. The root is the denominator. Okay, so you can take the exponent and divide by the root. So 12 divided by 3 is 4. So we have 3a to the 4th. So cube root of 27a to the 12th is 3a to the 4th. So let's take it up a notch, and now let's actually do a sum or difference of cubes. So what if we need to factor x cubed minus 8? So is there a way for me to rewrite this as a something cubed minus a something cubed? Well, cube root of x cubed is just x. Cube root of 8 is 2. So because this is a difference, I like to kind of write my basic formula out. Because this is a difference, my first sign's negative, my second sign's positive, the third one's always positive. So I need a minus b. My a is x, my b is 2. I need a squared, so this would be x squared, plus I'm going to multiply these two, so this would be 2x. And I'm going to take b squared. B squared is 2 squared. So write out your final answer. I have x minus 2 times x squared plus 2x. 2 squared is 4. Let's try another one. So what if I take it up a notch and I have 8x cubed minus 64? So again, I need to ask myself, can I rewrite this as a something cubed minus a something cubed? Well, my a here, cube root of 8 is 2, and cube root of x cubed is x. Cube root of 64 is 4. So I have the equivalent here of a equaling 2x, b equaling 4. So I always like to put the sign, so I leave myself some space. Since I have a difference of cubes, that means my first sign is going to be negative. My second sign is positive. The second one is always positive. So next I start with a minus b. My a is 2x. My b is 4. Next I have a squared. So I have 2x squared. Next I have a times b. So I have 2x times 4. And then I have b squared. Well, b squared is 4. So simplify, I have 2x minus 4, nothing to simplify there. Now 2x squared, this is the tricky part, okay? People forget to square the coefficient. You have to square everything, even the number. 2 squared is 4x squared, plus 2x times 4 is 8x, and 4 squared is 16. And we're done. Let's take it up another notch, the last one. X to the 12th, y to the 18th, plus 1. So we need to ask ourselves, can we rewrite this as a something cubed plus a something cubed? So the second one is easy. Cube root of 1 is just 1. But let's look at the first one. We have exponents. So remember our laws of exponents. If I have an exponent on the outside of a parenthesis, I'm going to be multiplying. So 3 times what will get me an exponent of 12? That's going to be an exponent of 4. 4 times 3 is 12. And 3 times what will get me 18? 3 times 6 will get me 18. So again, if you're utilizing formula, the equivalent of a is x to the 4th, y 6th. The equivalent of b is 1. And I like to write the signs first. Since this is a sum of cubes, the first sign is positive, second sign is negative, and the third one is always positive. So I start with my a. What is my a? My a is x to the 4th, y to the 6th, plus b. What's my b? 1. So next I have a squared, so x to the 4th, y to the 6th, all of that squared, minus my a is x to the 4th, y to the 6th, times 1, plus b squared is going to be 1 squared, so x to the 4th, y to the 6th, plus 1. If we square x to the 4th, y to the 6th, this means we multiply the exponents by 2. 4 times 2 is 8. 6 times 2 is 12. Again, x to the 4th, y to the 6th times 1 is minus x to the 4th, y to the 6th. And 1 squared is 1. So that is factoring sum or difference of cubes.